Welcome back, engineers. We are discussing common techniques and algorithms, and in this video let's have a quick UI and code demo about consistent hashing. I hope you're ready. Let's get started. So before we go into the demo, quick recap about what was consistent hashing. So if you recall this video, if you haven't watched this video, definitely watch it. It's called consistent hashing in the series. So this is like a prerequisite video for understanding the code demo, right? So quick recap, what did we discuss here? So let's say we have a set of servers and we want to have a uniform distribution among these servers, especially when the situation is such that the number of servers can change dynamically. Servers can be added, servers can be removed, and the problem that we saw was when we want to distribute data amongst these servers, whenever there was an addition or removal, simple hashing would not suffice, right? Because that would create a massive redistribution, which creates a large database activity, and it can also create potential downtime, right? So in order to avoid the situation, we are going to hash both the server and the keys of the data points, and we're going to use a consistent hash ring, which looks something like this, right? So there is a hash ring, which is a virtual concept. What we are essentially doing is saving a hash map with keys on the left side, server details on the right side. So the keys represent the hash representation of something. So we're going to pass in the server information like S1, S2, S3 and so on to a hash function, which will give out some kind of a position of the server on the hash ring. So we're going to maintain this position using a hash map, right? So the indexes will have the hashed representation of the server information, and on the right side we'll have the server details, right? And whenever we want to search for something, let's say we were searching for football players in our video, we were searching for Haaland, let's say. So we're going to pass Haaland to the same hash function, and we're going to get the position of Haaland in the hash ring. So this is how hash algorithm goes. So whenever we find Haaland's position, we go clockwise to the right until we find the nearest server object, and when we have that, we know the position of the server where our Haaland is. So we go to our hash map, get the server details, and we actually make the query to get Haaland, right? That was the algorithm for consistent hashing. Very simple algorithm. Let's go to the demo now. So just like in the previous video, I made a quick UI, simple UI demo, and there is a backend server running. Let me quickly start the server as well, and then we'll discuss how all this is working. So my FastAPI server is working, and this is my UI, right? So let's now visualize our current ring, which has nothing. So this is our hash ring, which is a simple dictionary object, right? And we're going to store key value pairs in this. And then we are also going to maintain a list of sorted hashes, which we will use for when we're actually searching for something in the node, right? And then this is the number of replicas we want, because we can maintain virtual nodes like we discussed in the previous video. We don't want to do a one-to-one mapping because that can create an uneven distribution in our hash ring. So what we'll do is we're going to create virtual nodes like this. Where is that? Right. So we're going to send S1. We're going to get some hash for S1, and we're going to maintain S1-1, S1-2, and so on, right? For the same server object, we're going to maintain multiple keys like this in our hash map. Okay, this will give even distribution in the hash ring, right? So that's what we're doing here. So depending on the number of replicas, we just iterate over a loop, and then we're going to create multiple virtual nodes for the same server. Okay, so let's now add a server. Let's say we are adding server S1. Okay, and if we visualize the ring again, we can see that there are 3 S1s created in our hash ring because of the virtual nodes concept, and we have 3 different hashes. I'm using MD5 hash here. Okay, so what we'll also notice is our sorted hashes is now getting filled because we are taking the keys from here and we are putting them in a sorted order. You can see here E plus 37, 38 and so on, right? So we're going to use this to find any key when we are actually searching for some key in this entire hash ring concept. Okay, so let's add a couple more servers. Let's say we have S2, and we can visualize this. Now we have 6 different entries, 3 for S2, 3 for S1, and we have 6 entries in sorted hashes, right? We can do the same thing. Let's add another server. We have S3 now. We can visualize we have now 9 entries, and we have a sorted list of hashes for these 9 entries. Okay, we could also remove a node. Let's say we are removing S1. We can go back here. We can refresh it. There is no longer S1 in this. Let's add S1 back again. And now we have all three servers in the hash ring. Okay. Now we can do a search. We can actually search for anything here. We can do user search depending on our data distribution. Let's say I'm searching for Apple, and we got the information that the key is Apple and the node is S1, which means our data is available in the S1 server. Okay. And let's search for Google. Okay. In this case, Google is also part of S1. Maybe let's search for Samsung. Now Samsung is in S3. Right. So now we have a uniform distribution among different pieces. We can search for anything. Maybe search for weather is in S1. Maybe search for Uday is in S3, and so on. So what it is essentially doing is taking the string called Uday and sending it to the hash function, getting a hash out, and then using the sorted hashes list to actually look for that hash in that sorted list using binary search. And then once we have it, we're going to get the nearest node. In this case, it is S3, right? So this was a quick demo about how consistent hashing works. Okay, now let's see the code. So from folder structure point of view, there's a new folder now, consistent hashing. There is a backend folder, there's a frontend folder. Okay, so in the backend folder we have ch.py, which is where we have our consistent hashing class, and then we have the server.py, which is just an API exposure to all the methods that we have inside consistent hashing. This is a simple FastAPI server, and on the front end we have a simple HTML file, which we have just seen in the demo, right? So we're not interested in server and the index.html. I'll leave it to you for exploring it. We'll focus on consistent hashing implementation, right? So we have the consistent hashing class. We have an initializer, a constructor. So we are initializing the number of replicas required. This is a configurable option. We can, depending on the option provided here, we can create as many virtual nodes to keep it evenly distributed. And then we have an empty hash string dictionary, and we have a sorted hashes list, which is also empty to begin with, right? So this is the hash function that will actually use the MD5 hashing, and we're going to get some hash out of any key that is passed into it, right? So let's see the methods now. For adding a node, we're going to enter into a loop because we want to maintain virtual nodes, and for each node we're going to have a hash key given out using this hash function. And then once we have it, we're going to save it in our hash ring, and at the same time we're also going to sort it and store it in our sorted hashes list, right? Every time we add a node, we're going to extract the keys out of the hash ring, sort them, and put them in our sorted hashes. Similarly, when we are removing something, since we have added multiple nodes, we're going to go through a loop, and we're going to get a hash for each of the node. And once we have the hash, if this hash is already part of the hash ring, we're going to delete it. And after iterating through this whole loop, we're going to remove all the virtual nodes, and then we're going to get the keys out of hash ring one more time, sort them, and put them in our sorted hashes list, right? So adding and removing is done, and let's now see how we can get our node. So for getting our node, first we get the hash key for whatever key has been given, maybe it's Apple, Samsung, or Google, whatever. So we now have the hash key. Now we need to search for the hash key in our sorted hashes list in a clockwise direction. So for that, I'm using bisect.bisect_left. So if you don't know what this function does, it is just doing a binary search operation and then getting the first hash that is greater than or equal to hash key, right? So this is what I'm using. So I'm giving it the sorted hashes and our hash key to search for, and we're going to get the first index that is already part of it. And we also have this concept that if nothing is found, we need to circle back to our initial position in the hash ring, right? That's why it's called a ring, if you remember. So this is what we're doing here. So if it is out of bounds, if the index is out of bounds after all these searches, so we are now left with nothing but to go back to the initial position. So we retain index as 0. So we're going to return the element that is in the index position here, right? So this is how consistent hashing works, guys. This is useful wherever we have a need for distribution of something among distributed servers, wherever there is a case of number of servers being changed dynamically, right? It can be used for load balancing, maybe for horizontal scaling and whatever. So definitely check it out. If you have any questions, definitely let me know. So this was a simple demo, guys. If you have any questions, definitely let me know in the comment. I hope you enjoyed the demo. I definitely enjoyed creating it. The code is available in GitHub. Definitely check it out. Thank you so much for watching. I will see you in the next one. Please subscribe if you haven't done already. I'll see you in the next one. Cheers.